All right, fantastic. Good morning, everybody. So my name is Brad Genereaux, and this session is on an introduction to DICOM and DICOMweb. My name is Brad Genereaux, and my colleague here, Hussain. We are both based in Canada and from Ag for Healthcare. So my role, I'm a product manager. I also do standards work. I'm a co-chair for DICOM for web technologies and the integration of information and imaging systems, as well as co-chair for HL7 imaging integration. And Mohammed is a software engineer, team lead of integrations and customizations, and coordinator for the SIM Hackathon, which is the Society for Imaging, Informatics, and Medicine. This is the first of 4 sessions in this track, so I'll be talking DICOM, DICOMweb today. Later today I'll be talking about IHE profiles in FHIR. Tomorrow I'll be talking about the intersection of FHIR and DICOMweb, and on Friday Mohammed will be leading a session on DICOM and imaging tools. Our goal is to understand the role of imaging in healthcare, know how DICOM and DICOMweb fits into it, and understand the basic concepts and structures of DICOM. We also have some DICOM web exercises that we'll do at the end of the session. So, the need for imaging everywhere. So what do I mean by imaging? I wonder if I can just use this mouse here. No, I definitely can't. Sorry. So there are really 4 different groups of when we look at imaging in healthcare, right? So we've got diagnostic imaging, the classical radiology, where we're trying to obtain a differential diagnosis or confirm a clinical suspicion. But the other groups are evidence imaging, where we're capturing just for documentation of the patient's state, like capturing a wound photo, for example, as well as procedural imaging. So down in the ER, you might have ultrasound cards looking at muscle tissue, things like that as well. And then also on the reporting side, being able to embed these images and really enrich the textual reports. When we look at what's known as enterprise imaging, it's a set of strategies, initiatives, and workflows implemented across a healthcare enterprise to consistently and optimally capture, index, manage, store, distribute, view, exchange, and analyze all imaging and multimedia content to enhance the electronic health record. Imaging is worth 1,000 words, right? So it seems rather obvious that while you can read text about a particular condition, having the images really makes a big difference visually for clinicians, for patients, for general staff. An old Google mantra is, if I can't find it, it doesn't exist. And that's really bad in imaging, because it means that we might have to re-image the patient. When we do that, we expose them potentially to more radiation, as well as possibility for hospital-borne infections, increased costs to the patient and the healthcare system by having additional unnecessary exams, increase the discomfort if they have to do contrast or injections, as well as anxiety for maybe the patient's spouse, the patient's family, delay for the patient because we have to re-image the patient, and possibly delay for other patients as we back up the healthcare system. Or we might need additional capacity just to handle these cases. Generally, an imaging workflow, we acquire images from a modality, we transmit them to a PACS. The PACS, the Picture Archive and Communication System, stores the images, the radiologist requests the images for reading, and then they create a report. But it goes much beyond this. That's the very simple use case. We can bring in prior studies, bring in images from other modalities, store them in vendor-neutral archives. We can visualize them with 3D software. We can bring in sites from other organizations, from other departments, and we can store them in regional or jurisdictional or national archives, embed them inside of EMRs, and use them on mobile devices, as well as share them in things like Patients Like Me and things like this. So what is DICOM? DICOM is imaging. It's a standard for handling, storing, printing, and transmitting information in medical imaging, and has both a file structure and a communication protocol. It's been around for since the 80s. It stands for Digital Imaging and Communication in Medicine. It's an ISO standard. One of the most widely deployed healthcare messaging standards in the world, outside of HL7. Hundreds of thousands of modalities are producing images, and these machines stay in production over decades. There are 2 trillion images produced annually, 50% in the US, 450 petabytes per year, and that's doubling every 5 years. And today, right now, we have 4.5 exabytes global in terms of imaging. That's a lot. DICOM defines formats for imaging, waveforms, and derived structured data, and provide the quality and metadata necessary for clinical use of those images. So you think, well, you can't just use JPEGs. There's a whole bunch of wrapper data around that describes about how the image was captured and what the image was acquired for. DICOM also defines workflow, as well as media exchange and printing, and it's all based on TCP/IP and then also HTTP, which I'll talk about with DICOM Web. It's administered by NEMA, the National Electrical Manufacturers Association, along with MITA, the Medical Imaging Technology Alliance, and you can just go to dicom.nema.org for more information. So as I mentioned, DICOM can store images, all kinds of images from all different kinds of modalities, and it stores metadata about it. So not just the pixels, but a significant metadata. Like for example, the patient's lying on the table, we store the table position as the patient moves through the unit. We can query on this data, we can sort it, we can route data to different destinations, we can manage the data. There are many different modalities. I've bolded a few that you might recognize, like CTs and MRIs and mammograms, but you can see that we actually acquire images from all sorts of different modalities. Aside from images, there's also the non-image supportive data. You might think of this maybe like metadata, but it captures information about it. So for example, if you've ever seen a fetal ultrasound, they measure crown, rump, and femur. These are measurements that are kept with the images and are transmitted to other systems. We also have the modality work list. We could do procedure step updates as the patient moves through the system. And there's also a whole aspect in terms of displaying the images. There's also distribution of images, storing analysis results, and there's a security model as well. So when we look at DICOM, there is a hierarchy of images. So we've got a patient who contains a number of studies, and each of these studies can contain a number of series, and each of these series can contain a number of instances. So you think about an X-ray, you might take two views of a person, so from the front and from the side. That would be two different series of an X-ray. A CT study would be maybe with and without contrast, 100 images. You might have a series with contrast of 100 images, and then another series with 100 images without contrast. And that would comprise as part of a study. Each of these DICOM instances has her own set of metadata. These are DICOM tags, like the identifiers, the date of the study, the description of the study. At the series level, we have the modality that was acquired from, the description, the series number, and the instance has, again, its own set of metadata as well, like the height and width, the position, the type of object that it is. If you think about servers and clients, DICOM transcended that around even before, around the time of HTTP. So we have things like service object pairs, service class users, service class providers, which you can think about as clients and servers. We join these things together, a server plus an object, and it talks about a service that's being offered. As I mentioned, DICOM uses metadata tags. They use hexadecimal values, so 1010 is the patient name, 890 is the referring physician name, and it's all defined in part 6 of the DICOM standard. We use VR and VM to talk about the cardinality and the data type as well.
Quick question.
Yeah, absolutely.
On those tags, I see they're divided up into 2 segments. Does each segment have a meaning separate from the other?
Yes, yeah, absolutely. So the first 4 is the grouping. So for example, the 10 grouping is all data about the patient. So 10, like 11 or 12 might be the gender, the date of birth, and you can find all the patient data under that 10 grouping.
Cool.
And 8 is about the study, the order information, and there's different groups as well. And then vendors could also define their own private tags as well, which are separate groups out of this.
Thanks.
Yep.
One question.
Yeah.
Does it relate to fire? I mean, what I see is this.
We'll get there. Yeah, absolutely. So this is, I'm covering DICOM, which was, like, it's from 1987. So fire was still just a twinkle in Graham's eye, I think. So, all right. Actually, so was VHL 7 too. Yeah.
So you have mentioned somewhere that image storage in EHR and EMR, but I usually see in the usual workflows as it is stored in vendor-neutral archives, these DICOM images. So is it scenarios, medical workflows, where it is stored in these EMRs or EHR databases, is it?
So what we tend to see, and we'll cover a little bit about this more tomorrow, but a PACS would send a message to an EMR to say there's an existence of a study, and we'll provide the study instance UID or the accession number, and typically what happens is the EMR will call the PACS vendor's image viewer, usually a zero footprint web viewer, to visualize that inside the EMR. But the EMRs don't usually usually store the images themselves because they can become quite large. You think about an EMR is really good at storing discrete data in a database, that are maybe a kilobyte or 2 kilobytes. When we talk about a pathology whole slide image, we're talking about half a terabyte. And databases aren't typically well structured for that if they're geared towards this relational type of database. Let's see, where was I here? DICOM objects have unique identifiers, they're globally unique, and the DICOM files themselves are atomic, meaning that once they're created, they aren't changed. We can change the metadata around it, but if we're actually going to change something about the object, it gets a new identifier. And we can define key objects, which are a set of interesting images. So for example, if you've got 1,000 slices, and the tumor's on slice 292, we can actually take that so that other clinicians can jump to it very quickly.
So if you change the metadata, you don't need to change the identifier, isn't it? And
For example, if the patient gets married and their name changes, in that case you don't have to change the identifier. But if you're going to change, for example, left or right, because you messed up the laterality, you change the instance. You retire the old instance and you use the new instance because you're significantly changing the payload of the data itself. Okay? GSPS, so we don't, when we draw images, we don't destroy the pixels underneath. We use a layer on top where I can draw arrows and write text, draw circles and measurements and things like this. Also adjust brightness and contrast, flips and rotates, things like that. If you want to read the standard, if you've got that kind of time, yeah, absolutely.
so if you're you're saying that if you change the image content actually, so you have to if someone does it draw some annotation and burn it onto the image, so it means that they have to change the UIDs.
Good question. So no, when you create a markup, that's a layer that's a separate object that sits alongside the image. And a radiologist could choose to display that on top or not. So we'll have two objects. One is the image itself, and the other is the markup that goes on top of it. All right? So yeah, if you like some light reading, you can read the standard. There's 20 parts available on the DICOM website. So now I'll talk a little bit about DICOM Web. So this is the comparable to FHIR. It's the RESTful equivalent to DICOM. Right? When we look at some of the evolving use cases, we look at more of this idea of patient-centered care or enterprise imaging. We want to use mobile devices. We want to use cloud services. We really need to embrace the web. This is not something that we can do on the classic DICOM protocols. It's something that we actually had to leverage web to actually do this. So HTTP-driven services using REST complements FHIR services with the imaging study resource, and it really provides us incremental capability for DICOM when we had the legacy system, we want to layer on the HTTP services. When we don't need it, we don't need it. We can just use classic DICOM. So why? What's happened in the past, we had these massive imaging silos where we just put all the images in and they're impossible to get out. And DICOM Web really unlocks that, frees the content so that we can use today's technologies to get these images everywhere where they need to be. There are 5 services: query, retrieve, store, tasks, and server info. And really quickly on how they work. So for query, I pass this RESTful query where I'm on the studies resource. I would like to get all of the studies for John Doe. There's that 1010 tag where I pass that forward. and I get back a list of studies. We have some exercises that we'll do at the end of the session with Mohammed, which will walk us through some of these really quickly. So I won't go into too much detail. While retrieve, here I want to say I want to see some images. I say, give me the study 1, 2, 3 and the series of 4, 5, 6, and I get back a multi-part related response with all the images that were in that series. And I can ask for things like JPEGs or PNG files, whatever that I actually need to have. If I want to store images, I can use the store or STORs, which I'm posting to the studies resource, and basically the image and the metadata around the image, I get a response back saying that it's stored. If you want to build out tasks and workflow, I use UPSRX, which is basically I can say I would like to query items on a work list. So here I would say, give me all the items for Dr. Brad for me to read today. I get back a list of studies and away I go. And if I want, similar to the capability service that Fire has, we can say, give me using the options verb, and it gets back a list of services that server supports. Yeah, there's synergy with the performance there. We use both XML and JSON data structures, your choice. You can see the synergy between the two different objects. There I see the study date, the modality, that's a CT study for John Doe, and there's the study instance UID that I can grab there. And as I mentioned, you can grab all the different kinds of data types. It not only supports images, but also video and audio and waveforms and things like this. You can also grab the raw DICOM if you want. And then there's also the DICOM Web cheat sheet, something that I wrote. I was inspired by the Fire cheat sheet, and I made something very similar for DICOM Web. So with that, maybe I'll turn it over to Mohammed. We'll walk through some exercises if people want to pull out their laptops.
Got the exercise sheet here if anybody would like.
Yeah, go for it. Yeah, sure, I'll distribute. Yeah, absolutely.
I'll get the.
There you go. Great, thank you very much.
Thank you.
All right, who wants one?
All right.
There you go. Good. There you go.
One share.
Similar left. All right, 3 left. 1, 2, 3.
Can share one.
Okay, great. And we're out. Okay, Lana, take it away.
All right, so this will be a little interesting because I actually have to twist my neck all over to see this, but let's just start with a couple of quick things you should know about the exercise sheet. So first of all, the exercise sheet, you'll notice that we're using a server that's provided by SIM. So SIM is an organization in the States that holds an annual conference. They require an API key to be able to use the server. Today we're going to use a general API key that we're all going to share. That API key will be valid until the end of the conference, so until, let's say, Friday evening. You're more than welcome to use it as much as you want. However, afterwards, if you wanted to keep using this service, they do ask that everybody request their own API key. In case you're wondering, it's completely free. They just like to keep track of who's using the server. They don't want to be completely open on the internet. Are we clear on that front? Very good. So if anybody needs their own API key afterwards, feel free to get in touch. Find me in person, email me, tweet to me, whatever works. I'll be more than happy to show you. Okay? With that being said, again, let's see if I can twist my neck here. I usually use Postman for this. That's my favorite tool. And what I will do is I will create a request. I'm hoping most of you have used this before. If you've been playing with Fire, no? All right, try and follow me anyway. So usually what I will do is I'll go to my header. Let's start with a new fresh one. So in my header, I'm going to create an API key header. And then I'm going to put the API key hackathon orientation. That's it. Okay? And then what I'm going to do is I'm going to put in my URL here. So there's a request. Studies resources. Okay, so you see if I send in my request, and again I'm doing the first exhibition. So you see here is my URL. Is this readable enough or should I zoom if anybody's trying to read it? I can't hear. Zoom?
I mean, I guess we can meet here.
Zoom a little bit there, Mohammed.
See if it'll allow me to zoom. Okay, there. Is this a little better?
Yep.
So there's my resource. I'm asking for the studies resource. And then I'm providing a query parameter of patient name equals SimJoe. Now, in the example that Brad showed you in his presentation, you notice he used a tag number. So 1010, that was the tag number. Depending on the implementation you use, you might be able to use the user-friendly name or you might use the tag number. So in this case, for your own sake, I'm using the tag name just to keep it simple. Okay? So here I'm asking for last name Sim, and you see the caret. This is the way of DICOM formatting. It will format it that way. So last name, caret, first name. So in this case, I'm asking for someone last name Sim, first name Joe, and then you see the response below. DICOM Web always returns things in multi-part related, so always keep that in mind. You will need a multi-part parser if you're working with DICOM Web. And in here, you're going to find all the information from DICOM Web. So for example, there's the accession number. This is something a lot of people are probably familiar with. And there's the value of the accession number, okay? And you see for every one of them, there's a tag number. And then usually you'll be provided with a tag, quote-unquote, name. This implementation calls it keyword.
And what's the VR?
It's a very DICOM concept. It's basically the data type. So, you know, like if you think about integer versus string, DICOM actually has a long list. One of the easiest ways to learn about them is if you go look at the wiki page, like Wikipedia, for DICOM, they usually have a nice explanation of what VR types are like. It's much better than reading the standard for this. Just a little point.
Yeah, so that stands for value representation, and that one is a value type of short, which is a short string.
Yeah, and there's, in this case, modalities and studies. So CS is a code string, I believe, right?
Yep.
Yeah, so this, in this case, the modalities in this study is CT, so like literally CT scan, KO, so that's key objects, and then, I don't remember what PT, PT is another kind of image. Anyway, we'll leave that. One other thing, of course, as Brad was saying, you can always ask for your format of choice. So if I say accept, I believe it was an application.
Is it case sensitive, like file?
Yeah,
Is your-
it is.
Yes, it is case sensitive.
And
Some implementations may choose to make it case insensitive, but usually it is case sensitive. So you see in this case, I switched it to application JSON, and I've got basically the same response. It's just in JSON format. The implementation we have running here, as you notice, once you go to JSON, doesn't actually provide the keyword. So I can't really easily tell which tag is which unless I have a library that maps it for me. Obviously, if you're going to get into DICOM or DICOM Web, you definitely want to use a library. It helps a lot. But nonetheless, if you want to keep it light, then XML may be a good choice for that. Okay. Keep in mind, not all these fields necessarily have a user-friendly name. Sometimes the names can be cryptic. So even if you are using the XML format, I would just take it as is and show it to the end user.
I'll say just really quickly, if anyone's very curious about this, the DICOM files produced 30 years ago are still valid using the DICOM and DICOM Web standards today. So if you wonder, why would we keep these awful tag names? And the reason why is that it still works. Because it's not like a database. We actually have these files everywhere, all over the world. And so that's why it's, we have an incredible backwards compatible way of doing this here.
Yes, and one other reason why these tags exist is also because originally when it was developed, it was mostly sequential reading, because these things were being read off tape. So if you're reading a 1 gigabyte object off tape, you couldn't easily just read the whole thing in the process. You had to read one bit at a time. So that's part of the reason why it's got all these like weird tags and structures. And again, you have to keep it backwards compatible to this day. I'll switch back to XML for the sake of this. Has anybody tried to do exercise 1, or would you rather do it for later? Okay, looking good so far. Very good. Let's move on to exercise 2. So exercise 2, you can choose to either. Sorry.
Should I ask now?
Yeah, go for it.
Go ahead. Yeah.
So in this groups, I we get the complete DICOM tags like pixel data also? Is it like
No,
we
this
don't
is just
get
the
that.
query so far.
Okay.
We haven't gotten to the pixel data yet. That's, I think, exercise 3 on the list here. Yeah, exercise 3 is when we're actually going to see that. But right now, this is just a query. This is what I'm saying here. Let me see if I can find a way to put this up in a more readable format. Actually, let me just go back to XML.
That's going to be hard to type.
So if I go, I'll bring this up in Notepad++, and maybe a little bit more readable. But what it is saying here is that it's actually returning, if you notice there are 4 parts in this response, I believe, or actually maybe 2, I can't remember exactly. But each part of this response is a study. So in this case, I'm saying, tell me what you have for this patient, Joe Sim. It's coming back saying, here's one study, another study, et cetera, et cetera. Each part is a study. Okay? Now, we can find, this is actually just giving you information about the study. If you go through the hierarchy, then you go down, and then, if you request for more information about the study, that will lead you to information about the series within the study. And then you can get to the actual images within the study, and that's when you get to image data. So that's the whole point. So exercise 1, you start at the very top of the hierarchy, patient. Second, you go to study. Third, you go to images. And then 4th, I show you how you could retrieve a whole study if you wanted to.
So if I am using DICOM Web, then I have to go through a layer by layer structure. Like when I am using the traditional DICOM, then I get the DICOM file where I have all the tags with the complete information. So
Well, it depends on which information you have. So if you have the identifier for the study and object you want, you could just go and retrieve it right away. In this case, like we're going at it from, let's say, someone who's building a little app. So maybe I'm building an app where I want to be able to search on my phone. If you needed to start searching from a human sort of discoverable way, you probably want to start at the patient level, right? Okay, so I'll go to exercise 2. I will actually cheat in the interest of time and copy the URL from my document.
Maybe we have like, what, 5 minutes left?
10.
Oh, 10.
Yeah, a little bit less than 10. So once again, the structure here is relatively simple. Brad mentioned the unique identifiers. They are very long, but that's the reason why, because they're unique. You need something that can be guaranteed to be unique. So in this case, I have the identifier for my study. Okay. You could use accession number to discover this identifier, but this is the unique identifier. This is the ultimate choice. That's what you want to use to be really sure. And then if I click send, then this actually here will return. I'll copy it to Notepad++.
I'll say DICOM solved the problem of what if you have an accession number from Hospital 1 and also from Hospital 2. By using study instance UIDs, each institution has to have their own OID starting point, and they register that globally, and then that way when they generate images, it's always going to be globally unique.
In here you see it's actually returning more information about the study. So the information you'll get here is different from what you're going to get at the patient level. Okay, so patient level you'll be interested in things like the patient's age, potentially address, that kind of stuff. Here you're interested more in the study. What time was the study done? What modalities, so what kind of devices were involved in the study, and so on and so forth. Okay? Yeah, go ahead.
Does it function in the same way as security IO of RS, that if you provide more arguments in the request URL that you get more of the tags available? Or
Yes.
Does that depend on the implementer, or is it a standard?
No, there's
way?
a standard way to do it. So it's called include fields. It's a magical parameter that you repeat for every field that you want to add.
Ah, okay.
It's the sort of the equivalent of adding your fields in the C file. If you want it, I'll be more than happy to show it to you later. Okay, so now let's see some images. I don't think everybody just.
So what you're saying that you can add multiple fields like you do it in case of C-file, like
Yep.
Here itself you can add multiple fields at any level.
Correct.
Yep.
Basically what it will do is the server will typically return a default set of parameters, and these defaults are not guaranteed. Like one server may choose to return the patient's sex, for example. Other server may not choose to unless you explicitly ask for it. So it's a way of specifying what you want back. If you need more information back, you have to tell it in advance. You can't assume you'll get that.
And you could use Keto for not just to say, I want to see all of Mohanad's studies. I could also say, show me all the studies for the CT unit today. And I would get a work list of studies that came out today.
Do this here. So let's see some images just because we want to see some pixel data, right? In this case, I'm going to keep it simple and just ask for the JPEG image. There's an image here. Okay. Now I jumped ahead with exercises in the interest of time, but you have the sheet, so if you want to try one at a time, you're more than welcome to. Getting the quote-unquote binary data here really involves two things. You can either get the actual DICOM file, but then you're stuck trying to render it because it's a complex file. So the pixel data in the DICOM file is not typically stored in JPEG. It's typically a raw format, and usually 16 bits or 12 bits. It's not a usual 8-bit image. But you can ask for a rendering of the image, which is what you're seeing here. So here I'm asking for a JPEG rendering, and I'm getting exactly that.
And we can expect that from any vendor?
As long as they support this part of the standard, yeah. So it's part of the conformance statement that tells you the things they do and the things they don't do.
Is the minimal requirement to allow JPEG rendering? So
I don't know if there's a minimal requirement in that regard. Like I said, it's really up to the vendor. Yeah, but certainly I can tell you, like, if you look at the conformance statement, it's not something where they lie. They either implement or they don't.
Where my standards hat is not mandatory, but what I've seen is everyone has implemented it. I just had to do for the ONC a collection of DICOM Web support across the industry, and almost all vendors in their public conformance statements, which are available along with their HL7 and IHE conformance statements, list what they support on for DICOM Web.
So once again, I'll be around if you want to go through more exercises or you have any questions, as well as Brad, but I'll give it back to Brad.
Yeah, so just to wrap it up really quick, and then maybe we have time for one or two questions, right? So we went through the exercises. So conclusions, DICOM is imaging, right? Standard for handling, storing, printing, and transmitting information in medical imaging, file structure, and communication protocol. If you want to find out more information, you go to dicom.ema.org. And then I also maintain a website, dicomweb.org, where I've got kind of cheat sheets and things like this. I recommend, if you're very interested, get involved in DICOM, as just like with HL7, it's free to join. You get on the mailing list, get information about it. There's two working groups that I think are interesting. I'm biased because I'm one of the co-chairs. You get emails, you can join the teleconferences. Again, no fee or obligation, and you just go and there's a link that you can just send an email to the secretariat. Special thanks to DICOM, Dima, Maida, Hims, and Sim, and a few of my colleagues in the industry, Harry, Jerome, Jim, Chris, and Kevin. And if you'd like to know more, you can follow the imaging track. The next session is at 2:45, where I'm talking about IHE. And then we also have an imaging table, which is in a different place this year. It's on this side of the building, and we have a nice spot by the window. It's very nice. So, any questions? And if you don't have any questions now, you can always reach out. You can tweet at me at Integrator Brad, find me on LinkedIn, or find me. I'll be around here all week. Any questions? Yeah. Back there?
There was too few of the...
Oh, yeah. Can we get more copies of the exercises?
I'm trying to ask.
Okay, great. Find that guy later. Yeah, any other questions? Yeah?
With the DICOM Web, we can store the store RS you have shown us. So we can store the images in JPEG and PNG with the DICOM tags in the headers?
Yes.
If that's possible.
Yep, absolutely. You can store the JPEG or PNG, and you also you upload a multi-part related, and the other object is an XML file which has what patient it belongs to and things like this, and then the server will combine that and store it as DICOM.
Okay, that's expected on every system.
Yep, absolutely.
And for
If
the
you've got
multi-thing
store rights, it's expected on every system.
So what's the best practice for integrating file with DICOM or DICOM?
Come back tomorrow. Tomorrow I will be giving a talk on Fire and DICOM Web. So we'll cover the intersection between the two, when you use one, when you use the other, and how they work together. And we actually, imaging integration, the HL7 group, and working group 20, the DICOM group, actually share the same co-chairs, and that's on purpose. So I'm co-chair of both, and the other co-chair is also co-chair of both, because we work together to make sure that Fire and DICOM Web work together and not compete in the same space. Any other questions? I think we're actually out of time.
Yeah.
So come find us later, come back later today, come back tomorrow, and come find me all week. I'd love to answer anything about imaging. I'm Hussain here as well. So thank you very much, everybody.